Hello everybody, welcome back to another LeetCode problem. Today we're looking at LeetCode1372, and that's called longest zigzag path in a binary tree. So as you can tell from the name, we're given a binary tree, and we're actually given access to the root of that binary tree, and we're told to find a zigzag path, which really is just what you might think it is. If you're familiar with the term zigzag, it means going left to right to left to right to left to right, or right to left to right to left to right to left. And one important thing they tell us here is that we can choose any node in the binary tree. So we don't care about the longest zigzag path from the root node. We care about the longest zigzag path at any point inside the tree. And they tell us how to do it. Basically, what we need to know is if from our parent we went to the right, we then need to go to the left. And if from our parent node we came from the left, we then need to go from the right in order to increment the longest path value that we want to return. And we can look at some examples here. So note that the longest zigzag path here is in kind of the middle of the tree. So if we go from the root, there's a zigzag path that gives us length 2 here. We went to the right and then the left has a value of 2. But the longest one takes us from the second node all the way down here. We get a value of 3. You see that output value of 3 right here. Another example here, we kind of traverse the whole tree and we get a output value of 4. And then an important case here that they give us is that if you have just the root node, there is no zigzag path at all, and the value that you need to return is 0. Okay, so we've looked at the picture now of a zigzag path. We can work through a diagram, but we want to figure out how to do this programmatically. So we want to start writing some code to figure out how to do that. And the question is how, of course. Well, first of all, I think if you've worked on a lot of tree problems, you can tell this is probably going to be a DFS kind of problem, a depth first search kind of problem. I don't think BFS is as good of a solution here. I think DFS really shines. And another thing we want to think about is we want to try to find a way to do this in big O of n time. We want to visit each node only one time. So we don't want to recompute anything. And the way that we can do that actually is we can store a Boolean in our inner function, which I'll show you in just a second. But basically what we want to do is we want to have some kind of memory in our stack calls that let us know which direction we came from. Because what that will allow us to do is to basically, anytime that a zigzag stops being a zigzag, we will know that and we can restart our counter. And we won't have to do any kind of recomputing. We can just do one DFS pass through the entire tree structure, and then we will know the longest zigzag path that there is. Okay, so let me show you what I mean. So let's get into the code. The first thing we've got to do is we've got to create a result variable, and we want to create that outside of our DFS function for like local variable issues. And then we want to write our DFS function. And of course, we need to pass in our node. And then we have that Boolean value I was talking about, and I'm going to call it isLeft. And what that really means is the parent, coming from the left? Did we call left node.left from the parent value? If we did, this is going to be true, and if we didn't, then it's going to be called false. And then finally, we've got the current zigzag path length. Now, notice that could be different from the total result here. So I'm going to call this current L. And as usual, I forgot to write the define keyword. Always forget that. And then if you've watched any of my videos, you know with DFS is really 3 things that we've always got to do. We've got to take care of the null case. So if we don't have the node, then in this case we can just return. We don't have to do anything. Otherwise, what do we need to do? Well, we need to increment our current length. If we've gotten to where we are, right, then that means that we've increased the length of our zigzag path. So current L is going to be equal to itself plus 1. Right, so we've taken care of the base case. We've incremented the value we care about. And so we've got one thing left to do, which is we've got to recurse. And this is actually where this problem gets interesting. So we're going to bring in that Boolean value, and we're going to say, oh, what are we doing? We're going to say if is left, meaning if we came from the left, then what do we want to do? And I think the first thing we should take care of here is let's take care of the positive condition. We'll do this if it isn't left also. So let's take care of the condition where we know that we're increasing the length of zigzag just to be kind of consistent. And so if this value is true, then what do we want to do? Well, let's try to go to the right. Let's call DFS on node.right, and then is left would actually be false in this case, and we'll keep incrementing our current L value. And then also, we've got to explore the whole tree with our DFS call here. So we're going to go to the right also from this position. Is left will be true again, but notice since we're going left and we had just come from the left, we're no longer zigzagging, right? That would be, we don't have an example over here. Well, we don't have any visual examples, but that would be like if we were, we went from here to here, and then we branched off over to the left again. We're not zigzagging anymore. So instead of putting in the current value that we've just incremented, we got to restart. We got to go back to 0. And then otherwise, if we're not coming from the left, if we're coming from the right, then what would be the positive case there? How would we increase the length of zigzag? Well, if we're not coming from the left, we're coming from the right. So let's try to go left, and then that will increment our current L value. We're now coming from the left, so is left needs to be true, and we can keep our current L value. Otherwise, we have one condition left. We can go to the right. This will be false, and we came from the right. We're going to the right, so we need a restart. We got to go back to 0. So that's how we use that Boolean value to try to zigzag if we can. But if we don't zigzag, still take care of the whole structure of the tree so that we don't have to do any kind of recomputing. And then we've got to initialize this function. So we've got it defined now, but then we've got to call it out. So, oh, one thing I forgot, one really important thing. We're not updating the result variable, right? So we're definitely finding the current value, but we need to update this result value. If I just ran this right now, if I called the function and then had a return value for the outer function, the one that actually returns an answer to LeetCode, we would get 0 every single time. So what do we need to do here? We need to update result to basically be the max between itself. What am I doing? All kinds of typos. And current L. Yeah, so we got to make sure we do that. And then now, finally, we can call our function. Well, this is kind of funny. Usually when we call DFS, we call it from the root value itself. But the way we've got these recursive calls set up, we're going to need to call it both from the left and the right to get it going. So we're going to do DFS on the root now, which will get passed in as the variable node. The root going to the left, is left will be true, and we will start it at 0, and then DFS root.right, false, starting from 0, and then we can't forget our outer return, which is going to return that result variable. I'm just scanning this now to see if I see any real obvious errors. I always tend to make a couple of those when I'm trying to talk and code at the same time. Okay, this looks all right. Let's go ahead and run our test cases real quick. Okay, we passed all of the test cases. And remember, we have to, this one's kind of funny. We could set up current L to be initialized in certain ways that this would fail. So that's why we have to start the initialization at 0. What will happen basically is, we never get to this line of code, this current L plus 1, because if we have only one value, then node.left is going to go nowhere. There'll be a none value. This will return, and we'll end up just returning this 0 value. All right, this looks pretty good. Let's go ahead and submit and see what this looks like. Hopefully we pass all the test cases. Okay, cool, we did. And pretty decent runtime, not in the 90s, but whatever. And pretty good memory, so relieving. Anyway, I hope you guys enjoyed that. Pretty fun problem. Kind of getting close to backtracking, excuse me. If the states that we had to capture were a little more complicated than a Boolean, DFS plus memory is backtracking. So slowly working our way towards that. Anyway, thanks for watching, and let's do some more problems together real soon.